Hi, second grade scientists. Great to see you today. This is Mrs. Miller with lesson 9 of this science unit on the structure and properties of matter, where today we'll be talking about irreversible changes. In our last lesson, we talked about reversible changes. Do you remember what a reversible change is? Right now, I want you to whisper it into your hands. Ready, set, go. A reversible change is a change that can be undone or changed back. Okay, eyes on me. Let's see if you said the same thing as me. I said that a reversible change is a change that can be undone or changed back to its original state. So if that's what a reversible change is, what is an irreversible change? Can you whisper that into your hands right now? Go ahead. An irreversible change is a change that cannot be changed back or undone. All right, eyes on me in 3, 2, 1. So did you say something like this? An irreversible change is a change that cannot be changed back or undone. Nice job. Let's think back to our experiment with the crayons. What happened when we added heat? Yes, that's right. When we added heat to the crayons changed their state of matter. They changed from a solid into a liquid. You're correct. Now, what happened when we removed the heat and cooled the melted crayon? Do you remember? We had poured it into that heart-shaped mold and we cooled it. What happened then? You're right. It changed back from a liquid into a solid. That change was reversed. Would we see similar results with ice? What do you think? If we added heat to ice, what would happen to it? Turn and tell somebody next to you. Yeah, it would melt. And then if we took away heat or made it cold, really cold again, would it turn back to ice? Thumbs up, thumbs down. Yes, it would, right? So would that be an example of a reversible change or an irreversible change? Call it out in 3, 2, 1. A reversible change. How about with ice cream? If we took this ice cream, which is sort of a solid, right, and we added heat to it, would its state of matter change? Thumbs up or down? Thumbs up. It would. It would change from a solid into a liquid. You're right. Now, what if we then took away the heat and made it really cold again? Would it turn back into a solid? Yes, it would. This is another example of a, call it out, reversible change. Would we see the same results with everything? What happens when we add heat to a piece of wood? Can it be changed back to its original form? Turn and tell the person next to you what you're thinking. Ready, set, go. Eyes on me, 3, 2, 1. So you probably said something like, no, once you burn wood, it can never be turned back into that wood. It turns to ashes. That change is irreversible. It cannot be undone. So some changes are not reversible, and we call these changes, let me hear you say it, irreversible. That's right. Say it one more time. Irreversible. That's a long grown-up word. You got it, though. Let's think of some examples of irreversible changes. Can you try to name 3 irreversible changes across your fingers. That's a real challenge, but ready, set, go. Think of 3 things that once they're changed cannot be changed back. All right, eyes on me. 3, 2, 1. Here are some examples that I came up with. I wonder if you came up with any of the same. One example is baking a cake. Have you ever baked a cake at home? It starts out as liquid batter, right? And then when we put it in the oven and we add heat to it, we take it out, it can no longer be turned back into that cake batter. Now it is a solid cake, and no matter what we do to it, it will remain a solid cake. Ooh, this is a good one. What about roasting marshmallows? Yeah, so if we add heat to marshmallows, they become toasty, they change color, they become like a little bit melty, and no matter what we do, we can't change them back to their original state. What about pancakes? Have you ever baked pancakes at home? Similar to cake, they start out as batter. Once we cook them, they turn into a solid and they cannot be turned back into batter again. So let's try adding heat to an egg, just like we did with the crayon. Now make a prediction. Do you think that this change will be reversible or irreversible? And I want you to think about why. So first, call out, when I get down to 1, call out your prediction if you think it's reversible or irreversible. 3, 2, 1. Okay, now you're going to tell someone near you why you think it's either reversible or irreversible. Turn and talk. One, two, three, eyes on me. All right, well, we are about to find out. Are you ready for our experiment? If you would like to participate at home and do this at home, the materials are listed in your Google Classroom that you will need. You can pause the video here and get all of your materials ready. This is an activity that must be done with an adult. You cannot do this by yourself. And if you're in school, this is also an activity that you could repeat at home. But again, it must be done with an adult. That's right. Now, before we begin this experiment, you're going to need this activity sheet so that we can track our observations and our findings. So if you're at home, make sure that you've printed this from your Google Classroom. If you're in school, your teacher will give it to you. You can pause the video here until you are ready with your activity sheet. For our first part of this experiment, let's observe what the egg looks like when we first put it into the pan before we add heat. We're going to see what happens when we add heat to an egg. We need to determine if it's a reversible or irreversible change. So let's just start by seeing what the egg looks like when we first put it in the pan before we add heat. Okay, so we're going to draw a picture to show what the egg looks like in the beginning. So let's really examine it closely. First of all, what state of matter is it? Can you tell? I've put a raw egg in this plate just so we can examine the beginning part. Call out the state of matter in 3, 2, 1. Yeah, it's pretty liquidy, right? It's pretty much a liquid. There is the yolk in the center, which is not quite a liquid, but let's see what happens if we cut into it. Let's see. Oh, look at that. If we cut into the yolk, there is liquid on the inside, right? And what color is the yolk? Call it out. 3, 2, 1. Yeah, the yolk is yellow or orange. And the outside part is clear with maybe like a little bit of a yellow tint. And then there's even another outside part. I don't know if you can see it. Let me move it up. Maybe you could see it better. But there's another outside part here that is clearer than this part. Okay, so now I want you to pause the video here. I want you to draw what the egg looks like in the beginning. And I want you to label the different properties. Label at least 3 properties to describe what the egg looks like. All right, so here are the observations that I wrote down based on what I see. I can see that the egg is liquid. The yolk is like an orange yellow. The outside, right outside of the yolk, is a pale yellow. And then the outermost part is clear. Now, that is not, sight is not the only sense that scientists use to make observations. Scientists also use sense of touch. So I'm going to touch the egg to see what it feels like. So it feels kind of like slimy, feels sort of like a gel, and it's wet and it's cold. Okay, so we can write down those observations. Now, anytime that you touch raw egg, you want to make sure to wash your hands afterwards. So I'm going to do that right now. I'm going to pause the video, write down those observations that I just shared with you. If you're trying this at home, you can touch the egg yourself. So I said that it's kind of slimy, feels like a sort of gel. It's wet and it's cold. Okay, so here's what I added. Slimy, gel-like, wet, and cold. Make sure that you've written down those observations as well. Okay, so now we're going to watch what happens when we add heat to the egg. This is a time-lapse video, so you're going to see the egg cooking very, very quickly. It's really sped up. All right, so let's watch. You could see already that the outside of the egg is no longer clear. Now it's white, right? And look, as it continues to cook, do you see the brown starting to form? Well, look, and the white part is spreading into the yolk. You could see as I flipped it over that the underside is brown. Okay, so what did we add to the egg to change it as a material, to change its state of matter? What did we add? Call it out in 3, 2, 1. Yes, we added heat. We heated the egg. So now let's observe the egg. Now I cooked this egg for longer than I would an egg that I was eating because I wanted to really show you what happens if we add a lot of heat to the egg. So let's just take a look at it. Look at both sides. And as you can see, it's no longer liquid. What state of matter is it now? Call it out in 3, 2, 1. Yes, that's right. It's a solid. Can you please describe the other properties that you see to somebody sitting next to you, or if you're at home, you can describe them to your imaginary lab partner partner, your imaginary science partner, go ahead and share. What observations can you make? One, two, three, eyes on me. So I'm wondering if you notice any of the same things that I notice. First of all, we see this part of the egg, which is black. That part looks like it burnt a bit. Then we see some yellow underneath, right? But if I touch it, it's hard. It's no longer runny or liquidy like it was before. It feels warm to the touch. It's no longer cold. The outside part here is white instead of clear, and then we also see some brown parts on the outside. Something else that I noticed is before, when we looked at the uncooked egg, show you, because it was liquid, it filled up the shape of its container, right? It filled up the whole entire plate. But here, the egg keeps its own shape, and it's far less spread out. It actually looks almost like it's smaller, right? So what I want you to do is I want you to draw what the egg looks like now this is the middle part. We're going to draw the middle part. And just like we did for the beginning, I want you to write down all of your observations, all of the different properties that you notice. Pause the video here, and I'll see you back in a few minutes. Welcome back, everyone. So here is what I wrote down as far as properties, and this is my drawing. So I noted that the middle is black and burnt. Then the right outside of that burnt part, there's yellow. There's also some yellow on the inside of the burnt part here that you could see underneath the burnt part. There's yellow yolk. It's a different yellow than the orange yellow that was the yolk in the beginning part. It's more of a true yellow than an orange yellow. It changed colors. This part here is no longer clear. Now it is white. I noted that. And then the outside part on the edge is brown. I noted that. I noted how it feels. It feels hard, unlike the beginning, the uncooked egg, which was liquidy and slimy and gel-like. It's warm. It's a solid, and I also noted that it has an irregular shape. This one, maybe I should note, takes the shape of its container. So, takes the shape of container. So now, for our very last step, oh wait, one more thing I wanted to do. Since we cut into the uncooked egg, let's just cut into the cooked egg and just see what's inside. So it looks like there's yellow yolk, but as you can see, it's solid inside as well as outside. Okay, so now for our very last step, we've heated it. Now we're going to do the same thing that we did with the crayons. So with the crayons, we heated them, and then we cooled them. That's right. So please, in this arrow, write the word cool. That's what we're going to do next. Okay, here I'm putting the egg into my refrigerator, right in front of my cantaloupe. I know you all like to hear what's in Mrs. Miller's refrigerator, right? So I'm going to leave it there for a few minutes, and we'll take it out and we'll see if it's changed back into its original state. Make a prediction. Thumbs up, thumbs down. Do you think it will change back to its original state if we cool it? Well, we're about to find out. In the meantime, while we wait, I thought it might be fun for us to get out of our seats and do a little movement. We've been sitting for a little while, so please stand up, push in your chair, and we're going to do an egg dance. This should be fun.
Sit on your egg and wait. Sit on your egg and wait. Sit on your egg and wait. 1, 2, 3, 4 until it's time to fly like an eagle. Soar across the sky. Fly like an eagle up, up high. Sit on your egg and wait. Sit on your egg and wait. Sit on your egg and wait. 1, 2, 3, 4 until it's time to waddle like a duck and paddle with your feet. Waddle like a duck and then say quack, quack. Sit on your egg and wait. Sit on your egg and wait. Sit on your egg and wait. 1, 2, 3, 4 until it's time to peck like a woodpecker knocking on a tree. Peck like a woodpecker, tap, tap, knock. But until then, sit on your egg and wait.
All right, you may sit down now. I do hope that you enjoyed that silly little dance while we waited for our egg to cool. So even after you were done dancing, I let it cool for a little while longer. I left it in the refrigerator for about 10 minutes so it would thoroughly cool down. So let's make some new observations. Well, does it look any different from the middle part after we heated it, now that we've cooled it? Thumbs up, thumbs down. Interesting. Let me touch it. Okay, so now it feels cool to the touch. It does not feel warm anymore. Now it feels cool. But let's go through these other properties. Does it still have yellow here? Yes, it does. Give me thumbs up, thumbs down, okay? Does it still have that black burnt part? Yes. And that brown part around the edge? Yes. Is it still hard? It's still pretty hard. At least harder than it was when it was a liquid. I don't know if hard is the best word to describe this, actually. It's sort of like, maybe a better word to describe this is squishy. I'm going to cross out hard and I'm going to write squishy because it's not really hard. If it was hard, when I bang it on my plate here, I'd hear like a loud noise. It's more squishy. It's like spongy almost. Could write that too. But it feels the same as it did. Now, it's no longer warm. As I mentioned, now it feels cool. It's still a solid. And is it still in an irregular shape? Yes, it is. So what I want you to do now is in just a moment, you're going to pause this video again. I want you to draw another picture here of this middle part. The end part, what it looks like at the end. And should it look pretty much like it does in the middle? Yeah, it should. It should look exactly the same because the egg hasn't changed. Right? It hasn't changed back. And then I want you to label all of the properties again. So the only property that should be different is this one. It's no longer warm. Now it is cold or cool. Okay, and then I want you to go on. Since we filled out a sheet just like this yesterday for the crayon, I think you'll be able to do this now on your own, but I'll read through it with you. It says what tools are being used to change the eggs. So when we heated it, the tool that was being used was a stove. And when we cooled it, the tool that was being used was cool air, or you could even say the refrigerator. And then it says, when we began the experiment, the eggs, well, it's really egg, but the eggs were a solid, liquid, or gas. What do you think? Yes, liquid. When we applied heat, the eggs changed to a solid, liquid, or gas. Solid. When we applied cool air, the eggs changed into a... They didn't change. So we'll say still solid. You can even write, let's see, the eggs. I'm going to cross this out and say stayed a solid. Was this a reversible or irreversible change? Call it out. Did you say irreversible? You are correct. So you would write that there. Okay? So do your drawing. Label your picture. Fill in your answers. And then come back and unpause because we've got more learning to do. See you in a minute. I have a video for us to watch on physical and chemical changes. Do you remember which change is irreversible? A physical change or a chemical change? Call it out in 3, 2, 1. A chemical change. That's right. A chemical change is irreversible. It cannot be undone. A physical change can be reversed. It's reversible. So do you think cooking an egg is a physical change or a chemical change? Call it out in 3, 2, 1. A chemical change, you're right. We're going to watch this silly little video to learn more about physical and chemical changes. Physical and chemical changes. That wasn't a very nice thing to do, to rip the mouse out of the picture, but that was an example of a physical change. Now, when they burnt that part, it's an example of a chemical change. Forest, desert, cold region. Where would that go? In a physical change, appearance or form changes, but the substance remains the same. Looks like they went to the cold region. melting to water. Water, on evaporation, becomes water vapor. Ice, water, water vapor. All the products formed are still forms of water. Hence, this is a physical change. Ah! Yeah! There's a plate. Uh-oh. These broken pieces are still parts of a plate. Hence, this is a physical change.
Late?
Ah! When wood burns, a chemical reaction takes place. A new substance gets formed. This is a chemical change. Wood becomes ash. Here the substance changes. Look at this car. Over time, chemical reactions have taken place, resulting in rusting. This is a chemical change. When we light a matchstick, combustion reaction takes place. This is a chemical change. Ah. The end. Okay, I did warn you that that's sort of a silly video, right? But this video did show us some examples of physical changes and chemical changes. So let's see if we could name 2 physical changes across our fingers. It could be a physical change that you learned about through this video, or a physical change that you come up with on your own, or a physical change from an experiment that we did. Ready, set, go. One example of a physical change is, another example of a physical change is, one, two, three, eyes on me. So let's see, an example of a physical change. Well, one example is melting a crayon, right? We know that it's still a crayon, and it can be, that change is reversible. It could be cooled and then turned back into a crayon. Another example would be ripping paper. That's another example of a physical change. Another example would be, let's see, what's another example? Breaking a plate. Even if the plate breaks, it's still pieces of a plate. The substance hasn't changed, and you could probably glue it back together and turn it back into a plate. Now let's name some examples of chemical changes. Name 2 across your fingers. Ready, set, go. Eyes on me in 3, 2, 1. So let's see if you came up with the same ideas as me. One example of a chemical change is cooking an egg. Another example is baking a cake. Let's see if I could come up with even a third example. Oh, I know. When metal rusts, that's a chemical change. That cannot be undone or reversed. It's an irreversible change. It's a chemical change. All right, last but not least, I have one more activity sheet for you to do. I'm going to read the directions to you. This can be found as usual in your Google Classroom if you're learning from home, and your teacher will give it to you if you're learning from school. The directions say, draw a picture of a reversible physical change and an irreversible chemical change. Then write to describe each example. So here you'll draw a picture of a reversible physical change, and here you'll draw a picture of an irreversible chemical change. Then you're going to write to explain what you drew. Thanks for learning with me today, second grade scientists. I'll see you soon. Bye-bye.